Hey guys, this is part 3 of doing dovetails on the CNC. We're actually going to the shop and start cutting them. Part 1 was doing the CAD and Fusion, drawing a dovetail box. Part 2 was doing the tool pass and the cam and Fusion. And now we're gonna go and cut them on the machine. Let's talk about some of the prerequisites for doing this. Now, a vertical work table is an absolute requirement. You have to be able to mount your work pieces vertically, and you just have to have one. I'll post a link to mine in the top. And it should be obvious, but you're going to need a dovetail bit to cut out dovetails. This is an 8-degree dovetail bit. The degree is based on whatever you designed, and your design probably was dictated by the size of this bit and the width of the bottom. And at a minimum, you need at least one other bit, a 1/4-inch downcut bit. If you want finer tails and pins, you could go to an 1/8 of an inch bit. Usually mine are about 1/4 inch, so 1/4-inch bit works fine. I also use a 1/4-inch upcut bit for roughing. It could be a downcut bit, doesn't matter. I'm not doing an aggressive cut. So the thickness of your board is incredibly important for having the dovetails not stick out too far or be inside too far. Just measure them with micrometers, and if your planer isn't dialed in, you could always machine it out on your actual CNC machine to get them to be exactly the size that you have in your model. Typically 5/8 of an inch, 1/2 inch, or 3/4 of an inch. Having some way of repeating the x-axis with dogs is very important. So either use dogs or mount some other piece of something to have them hit. Of course, they need to be very vertical, so a lot of these things you should already have worked out in your machine. I like to use 3D printed toe clamps to hold things down. I'll put a link to these in the description, but you could really hold them down just about any way you want because there's really going to be no risk of hitting these on the machine. All right, take my board, shove it in, and just get it roughly out in the right position. And next you want to have some way of setting the Z0 to a very consistent location for that workpiece. And I use a metal 123 block. These are just very consistent in their sizes. You could use a piece of wood. That just would work fine too. The block needs to be probably at least twice as high as the depth of what you're cutting because you want to be able to mount some scrap behind it and clamp it down. I just feel the block with my fingers to kind of just make sure it's perfectly parallel. You could also throw a scrap piece on top and then just move your piece up until it hits it. Both seem to work about the same way for me. So when I did the tool pass and the cam and Fusion, the back left corner was always my origin. So I have to find the X and the Y on the back here. Now, you could use a touch plate to do it. I use my Heimer 3D sensor. I also find the Z here. If you're using a touch plate, you could always use this piece that you use to align it with and touch off there for your Z. If you're changing your bit out of your collet each time, you want to make sure you touch off on a consistent surface at exactly the same spot again and again for consistency. So you definitely would want to use a flat surface behind it to do that. And this is a sped up video of me using my Heimer 3D sensor to find the Z, X, and Y origin of the piece. And once you've found your X and Y origin, you really don't want to reset it. You probably want to save it in an offset so you can recall it and do it again and again. In fact, I have this offset saved in my machine, so whenever I want to repeat a dovetail, I just have to recall that particular offset. I have a whole video on offsets if you're interested in learning more about how to use them. And the key to preventing chip out is to support the piece with a piece of scrap. I'm using a piece of 3/4-inch MDF, and I set my stock size to be 3/4 inches of wider in the Y minus and the Y plus when I did the cam setup, and I discussed that, and this is exactly why. One of the things that I liked doing was to have the scrap piece go a little bit higher than the actual work piece. I also align the left edge to it, and that way I could use the same piece again and again. Even after I cut one of them, I just use it again. In the last video where I talked about setting up the tool pass for the tails, I have the outside of the workpiece facing out. So if I rotate it inside Fusion, I can see that the groove on the inside is facing away from me, and if I've already cut the groove, it will be away from me in my workpiece. So at this point I can start running things. I use a 1/4-inch spiral upcut bit to remove most of the waste. After that, I switch to the dovetail bit and I go ahead and do the dovetail cuts. One of my goals is to have a really clean cut. So I'm not too concerned about doing this as fast as I can. I want clean results over speed. And if you did everything right, you should have 0 chip out. At this point, I could unclamp it and rotate it 180 degrees, being sure to keep that inside face facing away. I use that same 1, 2, 3 block to set the height again, and I don't have to zero out anything because I have an ATC, an automatic tool changer, and all my bit heights are stored in my machine. I then go ahead and run the exact same toolpath again, and this works because my dovetails are all symmetric. If my dovetails were not symmetric, if I had, say, a gap on one side, you would have to export a left and a right side toolpath for the dovetail bits. For the pin board, when we did the cam in Fusion, we had the inside facing out towards you. So if you have a groove already cut, it should be facing towards yourself. Otherwise, everything else is pretty much identical to what we did before. It's just running a different toolpath. I use a 1/4" roughing bit to rough it out, just like I did before. And then I come through with a 1/4" downcut bit to do a finishing pass at the full depth. So at this point, we want to remove the side supporting material and blow away all the dust. But it's important to actually not remove it from the machine yet because you need to do some tests for the very first one that you end up cutting. Now you can grab the tail board and see how well they fit together. Now in Fusion, you set the stock to leave to be a negative amount, so hopefully they fit together, but they might be a little bit too tight or a little bit too loose. If it's too tight like it is here, you have to go back to Fusion and make the stock to leave to be a larger amount, have it cut more out. And so to do this in Fusion, I would select the finishing toolpath, double click on it to edit, go over to the passes tab, and we had the stock to leave set to 4/1000 of an inch. We would want to make it a little bit bigger, like 5/1000. Hit OK. And I would go ahead and just right click on this individual toolpath, the finishing one, and I would go ahead and post-process just that toolpath and run it again to clean it up and make it a little bit smaller. And just like before, you would rotate 180 degrees, keeping that same inside face facing you, and run the exact same toolpath again. At this point, the box should go together pretty good. If you have issues, such as them being a little bit proud or a little bit inset, it's probably the thickness of your wood or your Y touch-off wasn't quite perfect. So I would look into those things first before anything else. So that's pretty much it on how I do dovetails in my CNC machine from start to finish. If you have any questions, ask in the comments. I'm happy to help. And thanks everyone.